Very welcome, dear students. In this video, we are going to cover the first chapter of class 11th physics, that is units and measurement. And I will tackle the chapter in the way I learned it when I was doing my 11th class. So I hope you will get really benefited from this video. So let's start. The chapter starts with the one introduction where we talk about the measurement. So measurement of any physical quantity involves comparison with a certain basic, arbitrarily chosen, internationally accepted reference standard called unit. Now here the focus area should be physical quantities. So physical quantities are those quantities that can be measured. So if we can measure a quantity, we can call it a physical quantity, such as length, temperature, pressure, etc. Now, to measure physical quantity, we need certain standards. Certain standards, what you can see, these are called the reference standards. Now, what is this standard? So these standards are not universal. So it is actually arbitrarily chosen. We just choose it for the sake of, choosing it. And then it is globally accepted. So internationally it is accepted. So first it is chosen, and then we try to make it simple, so it should be basic, and then it should be internationally accepted, and we measure it in units. In units means one quantity of that chosen reference standard. For example, to measure length, so distance is chosen. How? There is a process to it, and that is done by the SI system of units, International System of Units. Now they choose one distance and they call this distance 1 meter, and this 1 meter is the unit. Alright, and that is the unit of length. So whenever we do measurement, so the result of a measurement of a physical quantity is expressed by a number like 1, okay, or any numerical value. It can be 10 meters also. The result of measurement can be 10 meters, okay. So there is a number always, that is 10, 1, 125 or 12.5, okay, something like that, along with, so accompanied with by a unit, so like meter. So we write it as 12.5 meter. Okay, now although the number of physical quantities appears to be very large, there are so many different kinds of physical quantity, but we limit it. We need only a limited number of units for expressing all the physical quantities, since they are interrelated with one another. So for example, we talk about one physical quantity called length. So length, and the unit is meter. And let's talk about time. Time is another physical quantity, and we measure it in second. And we divide length and time, then we get speed, that is meter per second, so which is another physical quantity. So what I mean to say here, that physical quantities are interrelated. So that's why we don't need a lot of physical quantity. We need a certain basic physical quantities to express any other physical quantity. Okay? The units for the fundamental or the base quantities are called the fundamental or base units. So there are fundamental physical quantities. They are 7 in number, internationally accepted now. Okay? And for them there are 7 base units. The units of all other physical quantities can be expressed as combinations of the base units, as we discussed. So if we know these 7 base units, we can then apply it to find more physical quantities and find the units of other physical quantities. Okay? Such units obtained for the derived quantities, okay, are called the derived units. So there are fundamental physical quantities or the base physical quantities. For that we have base units. The same way, then we have derived physical quantity. So suppose we talked about time and length and time. So time divided by, it's not time, it's length divided by time becomes speed, and that is another physical quantity, and this is called the derived physical quantity because we derived it using 2 other base physical quantities. All right? Okay, now a complete set of these units, both the base units and the derived units, is known as the system of units. So if we list all the base quantities and base units, and we list all the based physical quantities, derived physical quantities and their units, then we can call it, all the units can be called as system of units. Now let us talk about the international system of units. In earlier times, scientists of different countries were using different systems of units for measurements. Okay, so in England it was different, in certain part of the world it was different. So it was tough to do the business. Suppose somebody wants to sell cloth from India to England, and if there is different way to measure cloths here with different units, then it will be very difficult to actually do the business. How much cloth you sold from India and how much they received was making no sense because both of the countries used different kind of system of units. 3 such systems, the CGS, the FPS system and the MKS systems, were in use extensively till recently. So still, so when it all started, it was big confusion because every small countries had different way of measuring things. So for example, the length was also measured in thumb. Your thumb in your hand, the fingers, that was the measure of length. So every person has different length of their thumb, but still thumb was used, and people used to use their thumb to measure any sort of length. So just think about how big confusion could be created. But then in the 19th century and the 20th century, the major systems of units were CGS, that is centimeter, gram and second, FPS, foot, pound and second. This was mostly used in England. And then there was MKS, meter, kilogram and second. And these are our recent history. Now, the system of units which is at present internationally accepted for measurement is called Système International de Units. That is like the French version of International System of Units, and it is abbreviated as SI units. The SI, with a standard scheme of symbols, units and abbreviations developed by the Bureau International des Poids et Measures, the International Bureau of Weights and Measures, BIPM, one institution in France, in 1971 were recently revised by General Conference on Weights and Measures, and then in November 2018. So the system of unit what the whole world is using is recently revised in the year 2018. The scheme is now for international use in scientific, technical, and industrial and commercial work. Okay, so everywhere in scientific work or in technical work or industrial or commercial work, this international system or SI system is used. Because SI units used decimal system, conversions within the systems are quite simple. So decimal system is quite important here. So using decimal system made it easy to do conversions depending upon the size of the quantity. So we shall follow the SI units in this textbook, okay? In SI, there are 7 base units given in the table. And they are length, mass, time, electric current, thermodynamic temperature, amount of substance, and there is one more that is called the luminous intensity. And the units are, as for length it is meter, for mass kilogram, time second, electric current is ampere, thermodynamic temperature is Kelvin, amount of substance is mole, luminous intensity is candela. Now, besides the 7 base units, there are 2 more units that are defined for the plane angle, delta theta, as the ratio of the length of the arc and radius. I will just show you all these things. And then there is solid angle. So plane angle, or in radian measure we call it delta theta, is actually the length of arc, that is called ds. This is in meters, length of arc, divided by the length of radius, so r. And this ratio is called the angle in radian measure. So whatever ratio you get, that is that much radian of angle. So if it is a full circle, and in full circle we know the arc length is the whole circumference, that is 2 pi r, and then we divided it by the radius r and we cancel it, and then what do we get? It is 2 pi, and the full circle makes, as you know, it makes 360 degrees. So 2 pi is equal to 360 degrees, and that's why we can say pi is equal to 180 degrees, pi by 2 is equal to 90 degrees, and this is our plane angle, because we can draw it on a plane, just like the screen here. Whereas the solid angle is a bit different. Solid angle talks about the area drawn on the sphere divided by the square of the radius. So as you can see, solid angle, which is measured in asteradian, is actually the area on the sphere, enclosed area on the sphere, divided by the square of the radius. Now I recommend you to just go through the definitions of the quantities and the unit. So these are the definitions. You just go through it one by one, and even if you don't understand, try to understand it. Doesn't matter. Once you do a couple of chapters, by that time you will understand most of the terms. Okay, now let us go back to the next page. All right, also there are some general rules, and just giving you the glimpse of how big the size of a physical quantity is sometimes. So minute is 60 seconds, and 1 hour is 60 minutes, which is 3,600 seconds. One day is 24 hours and it is 86,400 seconds. And that for the year, it is such a huge amount here in terms of our unit for time. All right. The same way it talks about other physical quantity.